Okay, now that we've got our screw here, let's go back to our door assembly. Let's see, here's my assembly right here. And now let's add in a screw. And so insert component. Oh, can't insert yet, didn't save it. Need to do that. Let's go back to part 3 here, and then File, Save. And so we'll save that as a screw. Okay, now we should be able to go at it. And so insert component, now our screw is there. Just going to drop it into place. And so now we have to mate it up. So mate. Now, you can pick the actual center line, but I'm just going to pick the face, because the cylindrical face, it kind of knows that, oh, there's a center line involved there. And then we'll pick the hole, pick that face. I pick those two faces, and what it does is it puts in concentric, or not concentric, concentric. So that just basically means that it takes the two center lines and makes them the exact same. I hit enter. You see it kind of put it in there, so let's drag it out of place. Okay, and so the next thing that we want to do is I'm going to take my conical surface there, and I'm going to mate it up with that conical surface there, and then hit enter. Okay, so now my screw is in place. Now the one thing that will happen is you can grab the screw will turn. Typically, I will harp on everything needs to be completely constrained. This is one case where I won't harp on it, because if a screw spins around, I don't care. If you really get to the point where you need, your OCD says that it's got to be completely constrained, what you can do is take any of your features, and in this case it's easy, we got a flat here. I'll take that flat, I'll hold control next time, and I'll pick that outside surface, and I'll put a mate there, and I'll tell them to be parallel. In there. Now it will be fully constrained. But this is the only point where, oh, hinges. We have over constrained it. That's a bad mate. It's caused a problem. What caused the problem with that distance mate? Huh. Well, this is the fun thing with some of the mates, is sometimes weird things will cause problems with other ones. We're over defining everything now. How did that happen? All I put in was that screw. Okay. So this should be fun. Let's get rid of these mates on the screw. That shouldn't have caused problems. Okay. So why didn't you like my... What is it that did you not like about... Oh, you know what it is? It's, yeah, that was a bad on my part. I shouldn't have put those two surfaces together, because they probably don't match up perfectly well. So what we'll do is let's do the top surface, and we'll make those coincident. Okay, there, it didn't have a problem with that. That's all good. Once again, now if you want to, this is where we'll stick to this surface here, and I like getting the surfaces and not the lines because they're a little more stable. Now we can make those parallel. Oops. Or I can undo it. Those surfaces, make them parallel. Okay. Now that's completely constrained. And like I said, though, with screws, if they spin around, I'm cool with that, because screws are just naturally going to spin around. Okay. So, we got to do that 8 more times, or 7 more times, right? No, we can do a linear component pattern. And so, even better, we're going to do a pattern-driven component pattern. So what is that? So we're going to sit there, and what component do we want to pattern? Well, I want to pattern the screw I just put in. What driving feature do I want to use? Well, I want to use these holes that I just put in. And then there we go. All those holes are now filled with screws. Okay, so let's show something cool with the way that we've put all this stuff together. So when I put this hinge in, if we go look at the hinge, we can look at just the mates in that hinge. And so we put this coincident at a distance mate. I don't like how close they are. We're going to get rid of that. And just like the other one's an inch from the edge, we're going to do the same thing over here. So I'm going to go mate. I'm going to pick that surface. I'm going to pick that surface. And I'm going to tell you I want you to be parallel at a distance of 1 inch. I'm going to say OK. And I'm going to let it rebuild. And so notice something very cool. It moved the screws. It moved the pattern. All the holes. Everything is still there. Now based on, and so we can see the holes there, all based on, since it was all based around what that part was, and we just moved it around. So it's great to be able to move and play around with that kind of stuff. That's where it becomes very powerful. Okay, so the last thing that I think we need to see is we need to make an exploded view. Now I want to make an exploded view for when we do the assembly drawing. So what's an exploded view? An exploded view blows everything up so you can see the parts and see how it goes together. You might have seen this in if you've ever taken something apart and looking for replacement parts. This is how you would find them. So how do we go about doing an exploded view? Okay, so we're going to go to exploded view. And we've got an exploded view, and we're going to do explode steps. So the first thing that I want to do is I want to pick all of my screws. And so if I go and grab this first one here, I can sit here and actually yank it up. You see it moves the screw up, and I can even tell it what distance to move it up at, and so we're going to move it up, let's say 4 inches should be good. And so now that screw will move up, and the thing is we want to do it for more than just that one screw, so I'm just going to go here, I'm going to hold control, and I'm going to watch my screws fly out of my assembly as I pick them. Ooh. And they fly out. And so now all of my screws are moved up the exact same distance at 4 inches, and so that is good. And we'll hit done. Okay, explode step 2. We're going to pick up our hinge. 1 hinge. We're going to pick up 2 hinges, and we're going to move that up. And so now we're going to explode that hinge up. We'll make it halfway, and we'll say 2 inches. And then I'm going to hit done. And so now what I have is I look at it, and it's exploded out, and I can see what's going on. Hit OK. So if I go into configurations here, I've got default, and I've got my exploded view. So if I click on it, I unexplode it. If I click on it again, I explode it up. And I can have a bunch of different kinds of exploded views because you may want them for different things, so you can make a whole bunch of different versions, and that's all fine. A bunch of different ways to do it. And so there's couldn't remember if there's a way to do it here too, but we can always do it right through the right through that there. Okay, and so the next thing that we want to do is we're going to want to do what's called the explode line. So if you go into exploded view, explode line sketch, and what it does is it's going to bring up this routing line. And basically what it's going to do is it's going to say, hey, I want to know where these things are going. So what you're going to do is, well, I want eventually this guy to go into that hole. And then you can hit OK. And we'll go through there. And 1 second. Sorry, my line's not showing up because I made a mistake. So let's start over. Exploded view line. I'd pick the point. You can't do that because you've got that cylinder. we want it to go to the other cylinder or the edge. And so then it shows you, it's like, okay, that's what I'm going to connect. And you hit OK. And notice it puts the routing line in there. Now, we'll just do that for every other one. Now, if this was messed up and had a jog, and if I had this over here, I could click here, then I would click this surface and click this one, and it would draw the thing in. But fortunately for us, we're just going straight down, so we can just route away. Now, why do you do this in an assembly drawing? It's basically so you can see where the part's going. Now, see, this one kind of got messed up. That's because it's trying to go up first. So if I click that to have it go down, that will fix it. But this is to show you how the parts slot into place. And on this, it's really easy because you're like, well, yeah, obviously go this way. But on some of the more complex ones, this is not the easiest thing to kind of visualize what's going on. And fortunately, we just have to, this has to go by hand. And I picked that point there, which is not going to come up. I'm going to get rid of that point, go back to the edge. And then once again, this is facing up, so I'll just click that to get it to route correctly. It's a little bit of a manual process, but it's not too bad. And so there we go. Now we have our routing lines in. And so when we unexplode it, they go away. When we explode it out, the routing lines appear. And we can see what's going on. And actually, let's go back and edit the sketch because this one went a little too deep. So I want to bring that to here. Just want to change the coincidences to here. Make those coincident, and then I'll get rid of that one, and there we go. Oops. Of course I put it in a bad spot. So this is these are all actually 3D lines. We can play with them the same way that we would on a 2D line. And so now I want to make those two coincident. There we go. So now I fix that because I drove it too deep the first time. Okay, so let's go back here. Let's do something fun to end this out with. Let's go animate collapse. And there you go. You got a nice little video that shows you putting it together. You can start it over, and actually you can just put it on a loop and just watch it. And this kind of stuff is kind of neat to be able to, especially to show in design presentations and whatnot. And then you can save this as a video file, save it as an AVI file to stick it in a presentation. So it's always handy to be able to show stuff like that. And that is the end of our basic tutorials on assemblies.